Hi friends, this is Dr. Srinivasa Gupta, Professor, Department of Mechanical Engineering of VIGNANA JYOTHI Institute of Engineering Technology. As a part of course Dynamics of Machinery, we are now today going to discuss on numerical exercise on band brake. If previous lectures we have seen different types of brakes, we have discussed at length. Let us recollect the types of brakes we have discussed. Brakes are broadly classified into hydraulic brakes, pneumatic brakes and mechanical brakes. Our discussion is involving basically mechanical brakes only. In those mechanical brakes we have block brakes, block or shoe we can say, and pivoted block brakes and double block brakes and also band brakes. Last lecture we discussed about band brake and previous lecture we discussed about all these. Coming to band brakes, let us do some small exercise numerical problem. Before going to attempt this problem, let us just recollect how the analysis is made in band brake. Band brake basically consists of a band which is wrapped around the wheel, rotating wheel or drum we can say, and because of tensions in the band, two ends of the band is connected with the pivot point of lever as you have seen yesterday, and the tensions in tight side T1 we can say and slack side T2. So the tension ratio we have seen the derivation of this tension ratio in previous lecture, that is T1 by T2 equal to E per mu theta. Mu is coefficient of friction between band and the drum, and theta is the wrapping angle of band with the drum. And also braking torque to estimate, we can use the relation T1 minus T2 into R, where R is radius of the brake drum. Now coming to the applications, also we have seen all these are application: conveyor systems, elevators and lifts, agriculture machinery, marine equipment, small industrial machines, all these applications of band brakes. Okay, advantages and disadvantages, this is discussed at length. Now coming to the, this is the how we can derive the relation tension ratio as well as torque, braking torque. All these we have seen the derivation. Now coming to and difference between band brake and block shoe brake also we have seen. Now we will take small exercise problem on band brake. A simple band brake is applied here. Let me read and write the given numerical values. A drum of diameter 600 mm. So R is radius of the drum is 300 mm, 0.3 meters if you want to write in meters. The angle of contact of the band on the drum is 210. So theta is 210 degrees. The coefficient of friction between the band and the drum is, that is mu, is 0.3. The maximum tension in the tight side of the band is 2500. Maximum tension means tight side. T1 we are using the notation 2500 newtons. Then we need to find tension in the slack side. It is direct approach. That is, we know that tension on tight side by tension on slack side equal to E power mu theta. So theta is always required to be applied used in radians only. Then mu is given. So T1 by T2, T1 this is T1 is given. So T2 directly we can evaluate. Okay, tension on slack side. The braking torque we can use the relation braking torque equal to T1 minus T2 into R, radius of the drum. This is also straightforward substitution. So we can find these quantities. So we can understand that these are the things. So we can get theta in radians 3.665 and T1 by T2 we will get 3.003. Then after substituting T1 we will get T2 is 833 newtons. Braking torque T1 minus T2 into R. R is 600 mm given diameter, so radius is this 3.3 meters, and the braking torque we can evaluate. These are the things. And more effective problem, more lengthy problem we can take one more. and a band brake is applied drum of 500 diameter. So R is here 250 okay, R is 250 here, and the angle of contact is 220, theta is 220, okay, and the coefficient of friction between drum and the band is 0.28, mu is 0.28. The tight side of the band is attached to the brake lever at a distance of 40 from the fulcrum. You have seen how this band is wrapped around the drum and tight side and slack side. This is a lever, okay. So this is one, this is one. If drum is rotating clockwise, this becomes tight side, as you know that, okay, right. This becomes, if drum is rotating clockwise, then this becomes T1, this becomes T2. On the drum, I am drum with band, if you take free body, or a lever if you take, okay. This is pivoted at one point. The distance 40 is from the fulcrum to brake lever at a distance of 40 from the fulcrum. So this is the fulcrum and it is attached to the 40 The tight side of the band is attached to the brake lever at a distance 40 from the fulcrum. Okay, see, this is for 40 okay, and the slack side is attached to the 160 from the fulcrum, opposite side, okay, 160 this is, okay, slack side, T2 is slack side, you know that, tight side is this one, this is how much, 40 okay, and slack side is 160 This is a effort P, let us say, if we applied effort. Then the effort is applied at the end of the lever, 500 from the fulcrum. Okay, so this is effort applied 500 from the fulcrum, this and total 500. Okay, this one, right? Then let us say this is the fulcrum. Okay, anyhow, then we need to evaluate the effort required to apply brake if the brake torque is 1500. Braking torque is given 1500 Newton meter. The tension in the tight side and slack side you need to evaluate. This is a little bit lengthy problem. It's also very simple. We can see to find, we can apply the relation between tension ratio T1 by T2 equal to E per mu theta, and theta 220 degrees given. So we can convert into radians 3.84, and tension ratio if you use that, and mu is 0.28 and theta is 3.84. So if you find T1 by T2, you are going to get 2.93. So T1 equal to 2.93 T2. Coming to the braking torque, because we have two relations T in between T and T1 and T2, then we can evaluate, then only we can evaluate T1 and T2. So braking torque we can write T1 minus T2 into R. So R is given. So braking torque also given. So we will have one more relation T in between T1 and T2. So T1 minus T2 will get 6000 here, and previous T1 by T2 is 2.93. Using these two equations we can solve T1, T2. So T1 we get 9109 and T2 is 3109. Now to find effort, okay, second part of the problem. Lever equilibrium, let us take lever equilibrium to find effort, taking moments about the fulcrum. So this is total 500 is given. So here from fulcrum is this one, from here to, sorry, this is band, okay, band is attached like this to the drum. Okay, this is the fulcrum and this is the drum rotating, let us say clockwise. Then this is T1, this is T2, T1, T2. Now see moments about fulcrum, P into 500, okay, and T2 into 60, 160. This is and T1 into 40. Here it is T2 is what it is mentioned 160. Let us go through the problem. This 160 is slack side is attached at 160 from the fulcrum. Slack side it is given. So slack side means actually T2. Okay. So T2 into 160 equal to T1 into 40. Tight side is T1 into 40. So it is drum is, in this case drum is rotating anti-clockwise. This problem consider. Thus this becomes T1, this becomes T2. This is 160 given, this is 40 given, this distance in this case of this problem. Okay, are able to understand clearly the given data. Then if you take moments about fulcrum, then it is P into, this is the P into 500, and T2 into, T2 will give this one, T2 into 160 equal to T1 into 140, T1 into 40. So this if you substitute these values, and you can find the effort P is actually this is P you are going to get minus 266 newtons. Actually the relation while we are writing, P is taken in this opposite direction. Minus sign indicates P is required to be taken as opposite direction. So this is the about effort required to find. So whatever distance is given from fulcrum to the pivoted points of belt ends, you have to exactly measure, locate the, mark the distances and take the moments. If you get any minus negative values, then it does mean initially taken direction of the effort. If you get effort negative, then initially taken effort value must be shown in opposite direction. Effort should be applied in opposite direction. That is only the meaning. This taking moments about pivot and all these are as usual, we are all familiar with that from the engineering mechanics, and all the concepts we are familiar. So this is about all these numerical exercise on band break. Next class we are going to, next lecture we are going to discuss on differential band break. With this I am concluding this lecture. I hope you are able to understand. Okay, thank you one and all.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.